Alright, welcome back. This is the second video for section 1.1. I'm just going to, from here on out, in this section, just work a problem from each of the sections in part 1.1 in the book. In the last video, part A, I forgot to find the area of that one problem, so I'm going to do one more of these problems with the triangle. So I did 49. I'll go ahead and do 50 as well, I guess. So problem 50. Let's see, we're given 3 points. A is negative 2, 5. B is 12, 3. And C is 10, negative 11. And the directions say plot each point and form the triangle ABC, verify that the triangle is a right triangle, and find its area. So it looks like I've got to go all the way down to negative 11. So it's got to go down quite a bit, and the highest I have to go is 5. So that's a total of like 16 units here if I'm going to draw this whole thing. So 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'll just put 2 more on for good measure, and then since I have to go all the way down to negative 11, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll put it right here. Alright, then I've got to go all the way over to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll go out to about there. 1, 2, 3, 4, that's 5, 6, 7, 8, 9, that's 10. 2, 3, 5, 6, 7. There's negative 10, negative 5. Alright, so let's see if I can plot these. Negative 2, 5. So I go over here. 2, 1, 2, 3, 4, 5. So there is coordinate A, or vertex A. 12, 3. So there's 12. Up 1, 2, 3. So there's B. 10, negative 11. So here's 10, negative 11 is right about there. So there's C. So that's quite a large triangle there. I don't know if I have a straight edge here to draw this with, but I guess I could use this graphing paper pad. So let's see if I can do it like this. Use this pencil. Alright. You know what? I'm going to freehand it. It's just too much trouble. Alright, so let's see. Alright, there's side AB. Good grief. Side BC and AC. Up there. Alright. So is it a right triangle? Let's look at the length of the sides. So it's a right triangle, remember, if the sides A squared plus B squared equals C squared. So if there's a right angle in here, it looks like that one, right? So that means that these would be the legs. So let's see. To get over from A to B, I have to go down 2. So I'll just do that thing with the triangle. I'll just go over. Looks like I have to go over about 14, I guess, right? Because I'm 2 on this side, and then I go all the way over to 12 and then down. So I think that's 14. And then down 2. And then this side, I go down all the way to here. And over 2. So that's 2, and that's what, from here up, let's negativize, that's 11, 12, 13, 14. So those two sides are exactly the same length, so this is another isosceles right triangle, right? And so I know that when I find the length of AB, that's also going to be the length of BC. So let's find AB. So AB squared, this side is 14 squared plus 2 squared. I think 14 squared is 196. Let's better make sure. 14 squared, 196 plus 4, right? Because 2 squared is 4, so that's 200. So that's 200. And then that's also going to equal BC squared, isn't it? Alright, so that means that, let's say AB is A squared and BC is the B squared. So then C squared is going to be the sum of, right, 200 plus 200. So 200 plus 200 is the length of AC squared. I guess I should make sure, because I'm trying to show that it's a right triangle, and here I am assuming it. So, but again, I can refer to the slope. So I know, for instance, the slope of this is negative 2/14, right? So the slope of this is negative 2/14 because you drop 2 and go over 14. And the slope of this line segment here is 14 over 2, right? Which is 7. So the slope of this one is 14 over 2, and it's positive. So right there, I already know that these are perpendicular lines, therefore that has to be a right angle over there. But for the sake of the lesson, we'll go ahead and calculate this. So it looks like I have to drop, let's see, I think 1, 2, 3, 4, 5 to get to there, and then another 11, right? So that's, I'd have to drop 16 on this side, and then I gotta go over 2 and 10 more, so I think that's 12. So 16 and 12 would be the legs of this right triangle, so that would be the hypotenuse of that right triangle. So let's see, AC squared is 16 squared plus 12 squared. What is 16 squared? 256. Yeah, 256 plus 144 should be 400. And it is. Alright, so since we see that AC squared is the same as the two legs squared and added, 200 plus 200, then that's proof that a triangle ABC is a right triangle. And now we're supposed to find the area of the triangle. So if you remember, the area of a triangle is equal to base times height divided by 2, right? So since it's a right triangle, it makes sense to let the legs be the base and height. So the base and height are going to be the same. And when I multiply them, well, what is the base? Well, the base is the square root of 200, right? So the base is the square root of 200, and the height is the square root of 200. Remember up here, 200 is what? 200 is BC squared, not BC. And I'm looking for BC, which is the actual length of it, not the square of the length. So I got to take the square root of 200. So the base is square root of 200, the height is square root of 200, and I divide that by 2. Well, that's 200 times square root of 200 times square root of 200 is just 200. And when I divide that by 2, I'll get 100. So that's equal to 100 units squared. Alright, so that would be the area of this triangle. So that hopefully completes problem 50. Alright, in the next section, find the midpoint of the line joining points P1 and P2. That's just the midpoint formula. I guess I'll do one real quick. They're pretty easy. Remember, all you have to do is find the area of the x's and the area of the y's. So, you know, smart thing to do if you're just, instead of just watching these videos, being bored out of your mind, you might want to pause it and work it out before I do. Right? So, and then if you want to fast forward through it because you know what you're doing, that's great. You use this video however you know you think is best. Alright, so to find the midpoint between these two points on the coordinate system, you just take the x values and you add them up. So that's 5 plus 3. You need to divide by 2. And then you add up the two y values, which is going to be 0. You divide that by 2, and that's going to be your midpoint. So what is this? The midpoint is, what, 8 divided by 2 is 4, and that's 0 divided by 2, which is 0. So that's the midpoint. So that's problem 55. Alright, in the next section it says, tell whether the given points are on the graph of the equation. So let's look at 63. So the equation is y equals x to the 4th power minus the square root of x. And the coordinates are that we're checking are 0, 0. So that one definitely is on there, because if I put a 0 here, because y is 0, and I make these both zeros, because x is 0, then you're going to get 0 equals 0 minus 0, which is 0, and that's true. So therefore I know without doing much work at all that this graph is going to pass through that point, 0, 0. We'll graph it here in a minute and we can see it on the calculator. Alright, the next one is 1, 1. So let's see if I can do that one. So if I replace x with 1, a 1 there and a 1 there, it's saying that the answer should be that y will come out to be 1, right? And I don't think that's true, because if this is 1, well, 1 to the 4th is 1, and if that's 1, the square root of 1 is 1, and 1 minus 1 is 0, not 1. So that one isn't going to be on the graph. Alright, and then negative 1, 0. If I put a negative 1 in there, I'm going to have a problem, right? Because the square root of negative 1 is I, which is a imaginary number. So I don't think that's going to work. This will. I mean, if you raise negative 1 to the 4th power, you'll get positive 1. But what I'll end up with is I'll get 1 minus I, which is not 0. It's just something that's not in the real coordinate system. So I don't think this one works either. So let's graph it and see what we see. Alright, so we're going to talk a little bit about how to set up your window so you can view your graph however you like. So we're going to go to y equal, and I'm going to do x raised to the 4th power. Let's see. X raised to the 4th power minus square root of x. Alright, so I'm just going to graph, see what comes up. Alright, so when I go to my window, I see that it's set up to standard window. So this right here tells you how far left you can see, right? So I can see all the way back to -10 on the x-axis, up to +10 to the right. This just is your tick marks on your graph, so you can see these tick marks are one apart, right? If I change that to 5, for instance, then there should only be one there, so that's 5 right there. So we'll leave that at 1. This is just how far down you can see and how far up you can see. So it looks like the graph starts at x = 0, and that makes sense because negative numbers aren't going to work here, right? If I go to my table, which is second graph, and go back and look at what happens at negative numbers, I see I have errors. And the reason I have errors, well, because you're taking the square root of a negative number, so that's not going to work. But here you can see that when x is 0, that y is 0. So just from looking at this table, I know that this coordinate right here is on the graph. And then 1, 1 is not, because when x is 1, y is 0, which is what we've already stated. Right? When x is -1, you can go up and see you get an error, not 0. Right? So we know that these are not. And this one is. Alright, if you want to see a little closer, like maybe I want to look at the details here, I could scrunch this up. So instead of stretching it all the way out to 10, maybe I could just stretch it out to, I don't know, 4 or something. So if I go into my window and change x max to 4, I can get a little bit better view. I don't need any of this really, do I? I mean, it's just, so I'm just going to go back to maybe -2, so window x min is -2. So now you can see that the x-axis goes back to -2. Right, can y'all see that? Hopefully you can see that okay. It goes back to -2, but goes up to 4 right there. And then you can see it dips down a little bit, right? So if I want to see that a little better, I can just get rid of all this space by making maybe my x minimum -2. My y minimum. So I'll go into my window, change my y min to -2. Again, you might want to, if you're not used to this, pause the video, do the same thing I'm doing on your calculator, see if you can get the same pictures. That would be a good idea. So now you can see that dip a little bit better. We could trace it and see how far down it goes, right? So it looks like it goes down to about, I don't know, 0.64 or something like that. 0.65, -0.65. You could actually find what the minimum is by going to second trace minimum, and then since you're looking for the bottom of that bowl right there, you want to go to the left bound, so you want to go over to the left side of the bowl, hit enter, then scroll over till you're on the right side of the bowl, enter, and then enter, and it should put me down at the minimum. So the minimum occurs when x is 0.55, and the minimum is -0.65. Alright, so just a little calculator stuff there. The stuff down here, we don't really, I don't pay attention to this. Honestly, I'm not familiar with what this is. There's a couple of formats on your calculator. If you go to mode, you can see that I have this math print in classic. So some of your calculators may be in classic, right? So I'm going to choose classic, and then it should change, like when I go to y equal, see, it's not that pretty print anymore. Instead of it having an x with a little 4, superscript 4 up there, now it has the caret and the 4. And when I go to graph, or to my window, if I go down, I'm not even sure if it is still there. Alright, well, anyway, So I think I'm going to leave it in Classic because some of you might have calculators that are in the only have the Classic mode. If you have a TI-84, you can download, you can upgrade your system software so that you can get the math print or whatever it's called. Let's look at it again. It is, yeah, math print. Alright. So that's problem 63. Problem 69, the graph of the equation is given, list the intercepts of the graph. Alright, so an intercept is simply where the graph touches or crosses the axes, right? So you have x-intercepts, you have y-intercepts. So if we look at problem 69, I'll just put the book up here. Here's problem 69. We can see that the intercepts are x equal 1, right? So this intercept would be 1, 0. This intercept would be negative 1, 0. And that's it. There are no y-intercepts. This is a hyperbola, and it doesn't have one. This one only has one intercept. It only has a y-intercept. It does not have an x-intercept. It looks like the x-axis is probably an asymptote, which means the graph will approach the x-axis, but will actually never touch it. So the only intercept is a y-intercept, and it is at 0, 1. Right? This graph right here has 3 intercepts. It looks like the domain of the function goes from negative pi to pi, and the range of the function is from y equals negative 1 up to positive 1 inclusive. So this is an intercept, that's a y-intercept, and it's at 0, 1. This is an intercept, right there, that's at what, pi over 2, 0. And this is an intercept, and that's at negative pi over 2, 0. Alright, so the rest of them you can do. You can see like the circle has 4 intercepts and so on. Alright. The next section, let's see. In problems 77 through 88, graph each equation by hand, plotting points, verify your results using a graphing utility. Alright, so graphing by hand. Let's look at, I guess we'll look at 81. Alright, so y equals x squared minus 1. Let's see, what do we know about this graph? Well, we might want to find the intercepts, right? So, since we're talking about intercepts, we might want to find those first. So, you find the intercepts by just letting x be 0 and letting y be 0, right? So, if you want to find the y-intercepts, let x be 0. So, if I make x 0, if I let x equal 0, then I get y equals 0 squared minus 1, and that's obviously negative 1. So when x is 0, y is negative 1, so that's an intercept. We can find the x-intercepts by letting y equal 0. So if I let y equal 0, I get 0 equals x squared minus 1. And then I need to solve it. So I add 1 to both sides. So that's 1 equals x squared. And then I take the square root of both sides, and the square root of 1 is 1, but it's also negative 1. Because when you square negative 1, you get 1, right? So I have 2 of them right here and right here. So there's all my intercepts. 1 and negative 1, and for the x, and then negative 1 for the y. And then we can find more points, right? So for instance, if you want to know, well, what is y when x is 2, we'll just put a 2 in here. So if I put a 2 in here, what is that? That's going to be 4. 4 minus 1 is 3. So if I put a 2 in there, I get 3. If I put a negative 2 in there, right? So what's negative 2 squared? Well, negative 2 squared is positive 4 as well. So that would be, if I put a negative 2 in, I get 4 minus 1 again. So negative 2 would also be 3. And you can see it's symmetric about the y-axis, and we could just probably sketch it from there. And it goes up forever. So that is an example of how to draw a graph by hand. And of course, you can stick it in your calculator. So let's see here. Y equals x to the second minus 1. Second minus 1. Oops. Alright, let's... Oh, that's not good. Like that. Alright, so graph. Alright, you can see our window is set from where I had it before. So let's say I want to set my window up. Say I want to see this picture right here, right? So I want to look at it like this. Right, if I want to see that picture in my calculator, then in other words, I want it to go down to negative 2, right? So that would be your y min, right? That's y min is negative 2. All right, and over here it goes over to 4, so that would be your x max. X max is 4. And your x min is what, negative 4, and your y max 1, 2, 3, 4, 5, 6, 7. So your y max is 7. Alright, so I'm going to do that on the calculator. If you know how to do this already, great. You can just skip it. If not, if you need a little practice, then pause it and do it before I do it. Alright, so let's see if we can set that up. So I'm going to go into Window, and my x min, I said, was negative 4. X max is 4. Scale, that's just where the tick marks are, right? So we're going to leave that at 1. We want a tick mark at every point here. What else? Y min, negative 2, that's right. Y max, 7. Graph. Alright, so now you can see that. Now what it does, though, notice it stretches out the x-axis, right? Because it's always going to fit this whole screen here. So since it's wider than it is taller, notice the tick marks between down here are further apart than here. So it stretches it out, you know, horizontally. All right. And the next section, let's see, problems 89 to 86. Graph each equation using graphing utility. Use a graphing utility to approximate the intercepts, rounded to 2 decimal places. Use the table feature to help establish the viewing window. Alright, so we'll look at 91 since it's in bold there, and it's 2x squared minus 15. 2x squared minus 15. Alright, let's put it in. 2x squared minus 15. Alright, I'm just going to take a look at it the way it is now. You can see that I can't see all of it, but I know since it goes to minus 15 that I'm going to want to go down that far. So if I go to my window, I'm going to want to set my y minimum to at least negative 15, maybe negative 20 or something. Gives me a little more room down at the bottom. So now when I graph it, I can see all the intercepts, right? I can see the y-intercept and the two x-intercepts. So that's a pretty good window. I guess I don't need to go down that far. So let me go and change that to negative 18. Alright. So it wanted me to use the table values, it said, right? So if I go to my table, what do we see? Well, right here I'm at when x is negative 1, and it's negative, right? So right here is where it changes from positive to negative. So that means that the x-intercept is somewhere between negative 3 and negative 2, right? Somewhere between negative 3 and negative 2. And if I scroll down, right there, it changes from negative to positive. So I know my other x-intercept is somewhere between positive 2 and 3. To find it really well, we can go back to our graph and I can hit second trace 0 for the x-intercepts. Right? Those are called zeros. So where the graph crosses the x-axis is called a 0. So I can scroll over. It says left bound, so I want to get here, so I need to be to the left of that. Alright, so since I'm above it, I'm also to the left of it. So I can hit enter, then it wants right bound, so I need to get to the right of this. So I'm going right. Okay, and then enter. So as you can see, the intercept is about what? Negative 2.74. Negative 2.74. Okay, and since it's perfectly symmetric, and I'm pretty sure the other one is positive 2.0 and positive 2.74, and I know that it goes down to negative 15, so the y-intercept is negative 15. Alright, so these are your three intercepts, two x-intercepts, one y-intercept on that. Alright, I think that's long enough for this video. There's a lot to cover in this class, so I'm going to do my best to try to make videos on all this material, but it is quite a lot. So I think I'm done for now, and I know you are too. So I'm going to go ahead and stop this one, and we'll pick it up a little bit later. Thanks for watching.